Problem 11. Determine how many two-digit numbers satisfy the following property. When the number is added to the number obtained by reversing the digit, the sum is 132. Assume the tens is A and the digit in the ones position is B. Then original number is 10A plus B. And reverse it. The number is actually 10b plus a. If we add them up, we will get 11a plus 11b equals 132, and 11a plus b equals 132a plus b equals 12. So we list all the possibility, and 6 plus 6 is equal to 12. Then 5 plus 7 equals 12, or 7, 5, 8, 4, 4, 8, and 3, 9, and 9, 3. So altogether we have 1, 2, 3, 4, 5, 6, 7 situations. Those are 66, 57, 75, 84, 48, 93, and 39. So 7 cases. Problem 12. Jefferson Middle School has the same number of the boys and girls. 3/4 of the girls and 2/3 of the boys went on a field trip. What fraction of the students on the field trips were girls? This problem is the easiest way to assume a detailed number which can create integer solution. And because the least common multiple of 3 and 4 equals 12, so we assume that middle school has 12 boys and 12 girls. Then we will have 12 multiply 3/4 and plus 12 multiply 2/3 equals 9 plus 8 equals 17. So altogether there are 17 boy and girl. We have 9 girls, so 17 over 9. And because everything is in proportion, so this is the base ratio. If we add a scaling factor, we can assume that we have 12x boys and 12x girls, and in the middle school. Then we multiply it, it will all cancel out. And so problem number 13. Two different numbers are randomly selected from set -1, -2, 0, 3, 4, 5, and multiply together. What is the probability that the product is 0? And if the product is 0, then one of the number has to be 0. The rest of the remaining number, I can pick one number out of 5, so it's 5 choose 1. And all the possible ways to choose two number out of this 1, 2, 3, 4, 5, 6 number set is 6 choose 2. So it is 5 over 6 multiply 5 divided by 2, and we actually get this is 3. 5 over 3 multiply 5, and we got 1/3. Problem 14. Carl's car uses a gallon of gas every 35 miles, and his gas tank holds 14 gallons when it is full. One day, Carl started with a full tank of gas, drove 350 miles, bought 8 gallons of gas, continued driving to his destination. When he arrived, his gas tank was half full. How many miles did Carl drive that day? The mile drive is equivalent to gas used multiply 35. And we will start it with 14 gallon, and one drove 350 miles, and we actually 10 gallon was lost, because 35 divided by 35 equals 10. Then we bought 8 gallons of gas and continue to drive, and then we will lose, say, X gallon of the gas, and the gallon was half full. Half full is that a full tank is 14, half is 7. So we will get that X equals, this is 4 plus 8 minus 7 equals 12 minus 7 equals 5 equals X. So here is X equals 5. And so this is 350 miles. Then he keep on driving for the distance, use up 5 extra gallon. So 35 multiply 5 and 175. 175 we have to add 350 driven before he filling up 8 gallons. That's 5, 12, 525. And problem 15. What is the largest power of 2? That is a divisor of 13 to the fourth minus 11 to the fourth. Let's try to use the square of difference to factor this number. And 13 to the fourth minus 11 to the fourth equals 13 square plus 11 square, and 13 square minus 11 square, and equals, and this is actually 169 plus 121, and 13 plus 11, and 13 minus 11, and that's equal to and 290 multiply 24 multiply 2 equals 2 multiply 145 multiply 2 to the third multiply 3 multiply 2. So we actually power of 2, we can extract 2 to the fifth multiply 145 and multiply 3. So this is the 32. And problem 16. Annie and Bonnie are running laps around a 400-meter oval tracks. They started together, but Annie pulled ahead because she runs 25% faster than Bonnie. How many laps will Annie have run when she first passed Bonnie? So Annie runs faster than Bonnie, and let's say that the speed of Bonnie is r. Let's use the formula r multiply t equals distance. So what we got is that drawing the table, and let's use the 400. So the distance and time, rate, and this is cases. And the first, let's consider the speed difference. So this is Bonnie, that's the rate, and this is Annie, and this is Annie minus Bonnie, and that's 1/4 R and 400. 1 divided by this, and 400 divided by 1/4 R equals 1600 R. So the T used is 1600 R. And this is going to be the time being used for everyone else. So that's going to use 100 R. And her speed is 4/5 R. And when we multiply those, yeah, it's actually R is here. R is on the denominator. Sorry. And so basically, when we multiply those two numbers together, R will cancel, and this is going to be 400, and then that's going to be 2000. So Annie would run 2000 meter when she passed Bonnie, and so that's 5 laps. And an ATM password at Fred's bank is composed of 4 digits from 0 to 9, with repeated digits allowable. If no password may begin with sequence 911, how many passwords are possible? So the total number of the choice is 10,000, because each digit I can rotate from 0 to 9. That's 10 possible ways. I have 4 digits, so that's 10,000 ways. And I cannot begin with 911, so that's minus, and 9 is fixed, so that's 1 way. 1 is fixed, that's 1 way. 1 is fixed, that's 1 way. Then the last digit can vary from 0 to 9, so that's actually 9 way. So the pattern of disallowed number 911, we have 10 ways, so minus 10 equals 9990, 9990. Problem 18. In an all-area track meeting, 216 sprinters enter a 100-meter dash competition. The track has 6 lanes, so only 6 sprinters can compete at a time. At the end of each race, the 5 non-winners are eliminated. The winner will compete again in a later race. How many races are needed to determine the champion sprinter? What we notice for each race, and of 6 persons, that 5 will eliminate it. So basically each race will take away 5 persons, and to determine a winner we have to take away 216 minus 1 equals 215 persons, and we divide by 5. 215 divided by 5, and that's going to be 43 games. 43 races need to be run before we determine the champion. Problem 19. The sum of 25 consecutive even integer is 10,000. What is the largest of these 25 consecutive integers? So consecutive number, it's 25. It has all number of consecutive number. So the median is equal to average. And so we can try to find the median by divide 10,000 by 25 equals 400. So the middle number is 400, and it's consecutive even, so the next one is 402, and we will count up 12 of them. So 400 plus 12 multiplied 2 equals 424. And problem 20. The last common multiple of A and B is 12. The least common multiple of B and C is 15. What is the least possible value of the least common multiple of A and C? The least common multiple of A and B is 12. So the least common multiple of B and C is 15. So 12 and 15 are both multiple of B. And so they have a common factor of 3. So if B is multiple of 3, if B is as big as possible, it's 3, then AC could be as less as possible. So if B equals 3, then A equals 4 and C equals 5. That all fit together, and the least possible common multiple of A and C is 20, because LCM 4 and 5 equals 20. Problem 21. A top hat contains 3 red chips and 2 green chips. Chips are drawn randomly, one at a time without replacement, until all 3 of the red are drawn, or until both green chips are drawn. What is the probability that 3 red are drawn? So for the red to drawn, basically the last chip need to be green. So basically red, green, red, red. So the last one has to be green. If the last is red, then actually green was drawn. So if the last is fixed as green, then the way to pick the first 4 chips basically is that how we arrange it's 4 factorial divided by 3 factorial and 1 factorial. It's just how many ways we are able to, it's a duplicated permutation with 3R and 1G. So that's actually equals 4. And then the total way, favored way, and the total is just equal to 5 factorial divided by 3 factorial and 2 factorial as a duplicated. So it's actually equal to 5 multiply 4 divided by 2 multiply 1, and that's going to be equal to 2/5. Rectangle DEFA shown below is a 3x4 rectangle with DC equals CB equals BA. What is the area of that wing shaded area? So here is 3. This is the narrow side. So this is 1, 1, 1, and this is 4. And because this is a rectangle, so this is a similar triangle and isosceles similar triangle. And this side is 3 because those are similar. So this side is 1 and 3. So the height is 1 and height of this is 3 and 1. So we can minus the area of the this is easy to calculate. Minus the area of the white area from the total rectangle, we can get the area. The rectangle is 3 multiplied 4 minus this right triangle is 1/2 1 multiplied 4. I have 2 of those, and then I have to minus 1/2 3 multiplied 3 and minus 1/2 1 multiplied 1, and this equal 12 minus 4 and minus 4.5 minus 0.5 equals 8 minus 5 equals 3. Problem 23. Two congruent circles centered at point AB each pass through the other circle center. The line contains both A and B is expected to intersect the circle at point C and D. So this is A and B and C and D. The circle intersects 2 points, one of which is E. What is the degree measure of CED? So this one is equilateral triangle AEB, and that's 60. And this is a isosceles triangle ACCE, and this is 60, and so this is 30, and this is also 30. This is 30. So CED is 30 plus 60 plus 30 equals 120. Problem 24. The digit 1, 2, 3, 4, 5 are each used once to write a 5-digit number PQRST. The 3-digit number PQR is divisible by 4. And 3-digit number QRS is divisible by 5. The 3-digit number RST is divisible by 3. What is P? This condition is most restrictive, so S has to be 5 because divisible by 5, S has to be either 0 or 5. There's no 0, so S has to be 5. And PQI is divisible by 4, so R has to be even. and the 3-digit is divisible by 3, so is 5 even, so it has to be equal to 4 or 2. So let's say that R equals 2, and it's divisible by 3, so the next one, it has to add, this is 7 add 2, and that's not allowed because it's 5 digits, and we add 5 is also not allowed, so either those do not work, so we have to, R has to pick 4, so 5 4, then the RST, T has to be 3, and so PQR is divisible by 4, and the R is 4, and the Q has to be 2 because remaining number is 1 or 2. 14 is not divisible by, so Q is 2 and P has to be 1, so answer is 1. Problem 25, a semicircle is inscribed in an isosceles triangle with base 16 and height 15, so that the diameter of the semicircle is contained in the base of the triangle as shown. What is the radius of the semicircle? Let's add a line from the top. So this is A, B, and C. And we drop a height that will, so this O will be the center of the semicircle. We also draw a vertical line from O, and that will be tangent to this semicircle. And so the base is 16, O will bisect 16 into 8 and 8. So the height is 15, and this is a right triangle. So AB will be the, use Pythagorean theorem, 15 square plus 8 square square root equals 225 plus 64 square root equals 289 square root equals 17. So this is 17. And so if we say the radius is R, and based on the similar triangle, so triangle A, let's say this is AD. ADO is similar to triangle AOB, and then R over 15, so that is the short leg over hypotenuse, is equal to R over 15 is equal to, this is short leg, this side is 8 over 17. And so by solving this, 17R equals 120, R equals 120 over 17.